Hi, this is JP O'Clair, and today I'm going to show you all the new features of FlashPreloadProfiler. So as an example, I'm going to profile this little particle system, which have a few different style here. So let's start. You have the minimize button to close any other window opened by the profiler. Then you have the runtime statistics. Those are you can find there the basic information of the runtime process. So you have the frame per second, current, minimum, and maximum. Same thing with the total memory, and I'm showing you here the free memory and private memory that are two new information available in the latest Flex SDK. You also have that little graph of very similar to what you can find in the Adobe Flex Profiler, and you have a little button here, little garbage icon. It's a force synchronous garbage collector. It's using the local connection trick, so you can find about that online. So if I click on the garbage collection, there will be a big drop in the memory here. You can see that it has been processed right away. One thing you can do here, you have those little two icons, is the actual transparency of the profiler. So I can say I want it to be more opaque or more transparent. So let's keep it this way. Okay, then you have the mouse listeners. This is going to show as a red rectangle. It's a bounding box of any sprite or display object that have mouse listeners to it. So mouse click, mouse down, mouse move, any other mouse listeners will display a sprite as its bounding box in yellow. Then you have in green or blue other kind of mouse listener. If the sprite is invisible but is on the stage and have mouse listeners, you will see it in different colors, and you will see a lot of button with this interface, so you can browse. In this example, it's not a good example since there's only one button and it's always there. Okay, then you have the overdraw. It's only showing all the bounding rectangle as semi-transparent rectangle here. So this is the little star particle system, and you can see that there's a lot of overdraw, which is all the sprites are being one over the other. You have also the display object on stage. There's about 130 display object on the stage, and the max depth is 6. So there's the relation parent-child of display object are at a maximum depth of 6. Okay. Here I changed the particle system. You can see the bounding rectangles of the particle. Then you have the display object lifecycle, which is very interesting because it shows what is being created, allocated, removed, reused, or what is waiting for garbage collection. In this example, there's a lot of reused, so all the little red squares mean that you have one sprite is being reused, so it has been removed from stage, then it is added again, but there's no allocation, memory allocation linked to it. And then you have all the big blue rectangle, which are when a sprite is removed from stage. That's the bounding box at the moment it is removed, so that's why it's a lot bigger. If I change the particle type here, this one is very interesting to look at. It has a lot of creation, so there's a lot of sprite being created in yellow, and then there's also some part being reused in red, following the mouse, and there's a lot of sprite being removed again in blue, and you can see also a lot of green squares. So there's a lot of sprites that are still animated and that are still managed and on stage, but that are not being collected yet. So they are dead theoretically, but they aren't removed yet from the memory, so they are waiting for garbage collection. You have the display object on stage, added object per second, removed, and the number of object waiting for garbage collection. So somewhere between 20 and 80 object per second are waiting garbage collection. And then you have the memory profiler. You have it looks a lot like the one in Adobe Flex Profiler, but you have also the deleted or removed or collected, whatever, object also. So you have for each object being created, I sorted by cumulative instance. So you have rectangle, you have, let's see here, event added per second, remove per second. The current is 0. This means that they are all added in one frame and removed in one frame, but there aren't any of those events that are still alive at the end of the frame. So they are not part of the garbage collector. They are part of the reap phase of Flash. And so you have shapes. So you have always the add number is most often bigger than the delete one, because, well, there's a lot of things waiting for garbage collection. If I trigger the garbage collector, I might see here 6,000 shape being collected. So that's the actual number, and that's about it. So I sorted. If you want to clear the data or reset or start over, there's a little button here, clear current data. So let's click that, and you have a lot of data that is being reset. Here I can show a few lines, but there aren't that many lines I can show in one screen, and I didn't want to create that scroll bar thing, so I just created one feature, which is copy to clipboard the old profiling. So you have save all, and if I just paste it in a notepad or something, I can see all the object, the whole thing without limitation. So if there was 2,000 object, different kind of object being created, they would be all there, and you have the same content. So add, delete, remove, and cumulative after the reset. So okay, and then you have the start recording samples. This is going to listen to every single sample being recorded by Flash. So instantiation, object garbage collection, and function processing. So it's a toggle button, so it's not recording for a lot of time. So you have to click on it, and as you can see, it is still in yellow, and when I click again, it's going to save everything in the clipboard. So I just let it run for a few seconds there, and as you can see, there is already 24,000 sample being recorded. So on the first column you have the time in microsecond of the event. You then have time it took to between two samples. So the bigger the time here, the bigger the time, the longer the event was. You have new object, deleted object for garbage collection, and other sample. You have the pre-render phase. As an example, you have, I can find other sample. For any instantiation or other sample, you always have the stack of what is being sampled. So if I can find something interesting here, new object. Okay, so there was an event here. It was the depth of a particle. So you have the whole stack here, enter frame, then update, and then depth. So the particle was dead at that point. Okay, so let's continue. You have the internal event profiler, which show you all the basic events of Flash. You have I've selected a dozen of the most frequent event, and you can see that in this example you have a lot of time being the pre-render phase. So since all the little particle there are sprites, they're using the display list, and there's a lot of computing going on to in this scene. So you also have in yellow and red here, yellow, red, and just red, the garbage collection. So marking phase, then sweep, marking, sweep, and I can, if I click a couple of times or on force garbage collection, you see a lot of sweeps going on. You also have free time in white here, and that's about it. So you have all the basic event Flash, and then you have the performance profiler. This is function performance profiler, so you can see all the function being run, how many time they took, self time in microsecond. So here the shape initialize phase took 0.02% of the time, so it's very small. And then you have all the function of Flash basic event, internal events, like I just showed you. Those are taking the most time. So you can see also the total amount, the total time being spent in one function and all its calls. So all the function being called by initialized. You can sort by total or by self time, and for each function you can see the stack that link to that function. So in this case, this is a stack, and I can click on it, and it's going to again save it in the clipboard so that I can paste that somewhere else. Alright. Then, well, you have that little help tab with a link to my blog, and you can navigate to it directly. And then you have that little monster icon. It's automated link to the monster debugger tool. If you have it running and you start the my profiler, it's going to link to it automatically. So you don't have to integrate it in the launcher of Monster Debugger. You don't have to integrate it in your Swift. You can just launch this profiler, and it's going to force a connection between the profiler and the Monster Debugger. So it's a pretty cool feature. So that's about it. Thank you for watching, and if you want more information on the profiler, or you want to see all the installation phase or comments from the other user, you can just go to my blog and enjoy. Bye bye.